All right, so today we're going to be working on one-step and multi-step inequality. So can you see what the difference is in inequality? Yes, Rashonda? Yeah. An equation and inequality. Okay. Yeah, so less than, greater than, less than or equal to, or greater than or equal to. They're called inequality signs. Um, and so an equation has like one solution for the most part, except for our special case, where it means that it's like x equals a number. So there's only one solution. However, when it comes to inequality, there's a vocabulary where it says that it is comparing quantities. So that means that it has more than one solution. It's everything that is either less than that number or greater than that number or less than or equal to that number or greater than or equal to that number. Okay? So this has more, it's technically more than one solution. All values that are greater than, less than, or equal to, whatever is that value. Okay? That's, it's important to keep that in mind. So the first thing that we're going to be doing is talking about graphing inequality. This isn't like on a graph, this is like on a number line. Yes. No? Yes. Homework, homework, board. All right, so when we write, when we are graphing inequalities, it's like on a number line, not on like a normal graph. Okay, you want to make sure that you write your inequalities so that the variable is on the left side and that your number is on the right side. Okay, so whatever you rewrite anything, keep in mind the side of the sign that is facing the inequality. Then we determine the type of circle. If it is greater than or less than, then it is an open circle. Like so. Let's show you. Like so. If it is greater than or equal to or less than or equal to is a closed circle, like a dot. Okay? Yeah. Then when we draw our arrow, because we have to draw an arrow for these, if it is greater than or equal to, the arrow will go to the right. And if it is less than or equal to, our arrow will go to the left. Okay? Because it shows that it's pointing towards all the values that are included. Okay? All right, so I'm going to erase. So we're going to graph these. When I'm graphing, I do not care that 0 is in the center of your number line. I think that you should put whatever value that we're going to be looking at. So -1, I'm going to put that in the center of my number line. So I'm going to draw a number line. I'll put -1, and then I just need to put a couple values on each side. So -1, this would be 0, then 1, -2, -3. All right, then we need to look at our inequality sign. It does not have an equal sign. So that means it's going to be an open circle, and it is greater than. So that means it's going to go to the right. Okay? So this next one here, draw my number line, and I put 0 in the middle because that's what we're looking for. 1, -1, -2. All right, so is this going to be a closed or open circle? Closed because it has an equal to, and it's less than, so it's going to go to the left. Okay, again, draw our number line, put our 2 in the middle, then we have 3, 4, 1, 0. Okay, is this going to be closed or open? Closed. And is it going to go to the right or the left? The right, because it's greater than. All right, so this one is not written properly, so we need to rewrite it first. So I need my x to be on the left, and then I need to rewrite my inequality sign. So the less than portion, the small portion of the inequality is touching the x. You see how here the small portion is touching the x? So when I rewrite it over here, the small portion needs to touch the x. Okay? Like so. So that means that x is less than 3. Because if we were to read it the other way, x is less than 3. Okay? Just keep that in mind when we're rewriting. So then I'm going to put 3 in the middle. Then I have 4, 5, 2, 1. Is this open or closed? Open. And it is less than, so we need to draw it to the left. Okay? So that's graphing. For our other problems, I'm not going to show the graphing portion, even though you need to graph them. It's just so that we can save time. Okay? So that's just the graphing portion. It's just once you get your answer, you graph it, like so. Okay? Can I erase? Okay. All right, so when we're solving inequalities, we are going to use the same steps as solving equations. So those steps are on the next slide. Distribute, multiply by the least common denominator, combine like terms, and the same equal sign. Add or subtract the variable to one side. If we get our special cases, so that's all real numbers or no solution. So all real numbers are identities is a true statement, or no solution would be a false statement. We're going to add or subtract a constant to the other side, and then we're going to multiply or divide to get the variable by itself. However, there is a special rule when it comes to multiplying or dividing. You multiply or divide by a negative number. Negative number. It's only negative. You multiply or divide by a negative number. It reverses the sign in the inequality problem. Okay, so that means that it's going to flip the sign. Okay, that's what it means by reverses the sign. So we're going to flip the sign if we multiply or divide by a negative number. Okay, only if it's negative. It's only multiplication and division. Okay, not adding and subtracting. Okay, all right. And that's what it says here, that if we multiply or divide by a negative number, we reverse the inequality sign. Okay, so these are just like our normal solving equation problems. So I'm going to add 6 to both sides. Okay, I didn't multiply or divide by a negative number, so I'm not doing anything with my sign. So negative 2 plus 6 is 4. And so n, and I need to rewrite this. So I have n. Greater than part is touching my n, so it's greater than 4. That's not changing my sign. That's not flipping the sign. That's just rewriting it the correct direction. Okay? Did you have a question, Cody? Why? Negative 2 plus 6 is? All right, are we good? That's right. If you have a question, please let me know. All right, so I'm going to add 1 to both sides. So I'm going to get x is greater than or equal to, okay, well, those ones cancel out. And then I have negative 3 plus 1, which is negative 2. I didn't multiply or divide by a negative number, so my sign stays the same. We would graph these at this point in time, but I'm not graphing them. Okay, so for this next one, how do I use, if this is a normal solving equations problem, I would have to do what? There's a 2 in front of my x. Divide by 2. Am I dividing by a negative number? No. So we're going to keep our sign. So 6 divided by 2 is 3. So x is greater than 3. So I would have a open circle, and it would go towards the right because it's positive. Hey, I have a fraction. How do I get rid of a fraction? Multiply by the least common denominator. So in this case, that is 4, but there's a negative. So I'm going to multiply by negative 4. Get rid of the negative as well. I'm multiplying by a negative number. So our sign is going to change. So I'm going to do that right away. Okay? Then my negatives cancel out and my 4s cancel out. So I'm just left with an x. Then 4 times negative 4 is negative 16. So there you go. And this would be a closed circle, and it is greater than, so it would be going to the right. Okay, can I erase? Yes? Okay. All right, so here, I have a variable on both sides. You can move whatever variable you want. However, you're going to have to, if you move the variable to the right side, you're going to have to rewrite it so that it is proper. However, if you move it to the left side, you might have to deal with negative numbers, which means you have to flip your sign. So it's whatever you want, okay? I would move it to the left side and just flip your sign so you're not having to worry about rewriting. However, if you think that you might forget to flip your sign, then just move the smaller, okay, of the two variables. So we need to isolate our variable first, so I'm going to subtract 4x from both sides. Okay, my 4x's cancel out here. I have 2x minus 4x, which will be negative 2x. I have not multiplied or divided by a negative number yet, so I'm not worrying about that step until the end. Okay, then I'm going to add 4 to both sides. Okay, these 4's cancel out here. I have negative 1 plus 4, which is 3. All right, then I need to divide by negative 2. So I'm dividing by a negative number. So what do I need to do with my sign? Flip it or change it or reverse it. So it's going to come instead of greater than or equal to, it's going to come out less than or equal to. The equal to still stays. So those cancel out, leaving me with x. And this can't reduce, so it's just going to be 3 over 2. And then we would traditionally graph it. It would have a closed circle, and it is less than, so it would be going to the left. Okay, if this was a normal solving equations problem, what's my first step? Distribute. So I'm going to distribute this 2. So I'm still going to have a negative plus 4, which is less than 2x minus 16. All right. So remember, you can move either variable. However, if you want to not have to rewrite things, then you should move things to the left. So I'm going to subtract 2x. Okay. Or move our variable to the left. We're going to be left-siders. Okay, so those cancel out. I have negative 1x minus 2x. That's going to be negative 3x. Okay, then I'm going to subtract 4 from both sides. My 4's cancel out here. I'm left with negative 3x, which is less than, okay, negative 20. Okay, then I'm going to divide by negative 3. I'm dividing by a negative number, so what do I need to do with my sign? Flip it. These cancel out, and I'm left with x. Then I have a negative over a negative number, so it's going to become positive. And I'm just going to leave it just like that, because it can't reduce. 3 does not go into 20 evenly. Yes. I would divide it, and as a decimal, it would be 20, or it would be 6.6 repeating, so it would be in between 5 or 6 and 7. Does that make sense? It wouldn't be perfect, but you don't have, like, the graphing portion doesn't have to be perfect, okay? All right, so let's look at the next one. I have fractions. How do I get rid of fractions? Multiply by your least common denominator. In this case, what is my least common denominator? 6. I'm going to multiply everything by 6. So that means that's going to be 6 times 1/3 x minus 6 times 1/2, 6 times 5 over 6x. Everything. So my 6 and my 3 reduces to a 2, so this becomes 2 times 1x, which is 2x. My 6 and my 1/2 reduce to a 3. and my 6's cancel out, leaving me with 5x. So in this case, because I only have an x on the right side, can I move it to the left side? Technically, yes, but it's easier not to, okay? Because I can move a 0 there, but then you're just making more work, okay? So I'm just going to subtract 2x from both sides. I'm going to get negative 3, which is less than or equal to 3x, okay? Then I'm going to divide by 3. My 3's cancel out, and I'm left with negative 1. I did not divide or multiply by a negative number, so I'm keeping my sign. However, we need to rewrite this with my variable on the left. The greater than, or the open portion of my inequality is touching my x. So when you rewrite this, the greater than or open portion needs to touch your x. Okay? Does that make sense? Okay. And then that's it. So that's why when we were solving equations, I told you not to like change it around, because then when you got here, you might mess up. So that's why I didn't want we to get in that practice of just waiting to change it until the end. Okay? All right. So here I have like terms here. I have 7y minus y. So that's going to become a 6y plus 2. Okay, this is a perfect example of why we need to add or subtract our constant, or I'm sorry, our variable before our constant, okay? So I am going to subtract 6y from both sides. I understand that they cancel out. However, I have 8 is greater than 2. Is 8 greater than 2? Yes, so this makes a true statement, which would make this all real numbers, okay? If it was a false statement, like 8 is less than 2, it would be no solution, okay? Yes. Identity, yes. Identity, all real numbers, any of the following. Sometimes they just say, they don't say all real numbers, they say, I don't know. They say real numbers, and not all real numbers, but all real numbers, okay? Identity, all real numbers, all of that. Infinitely many is another way that they put it. Sometimes they all mean the same thing. All right, so our word problems. So this is where we have to go back to our, when we're writing expressions, equations, and inequalities, that writing portion, you need to keep in mind those key words. So they're going to have an inequality in them, so you need to make sure you don't put an equal sign in them, okay? So you have $125, or you need at least. So we need more than $125, right? Okay. So at least $125. But we can have $125, so it will be equal to, right? Right now you have $65. Okay. Write and solve an inequality that will show how much more money you need. Well, if I add, I don't know why I put an X there, 65 plus X, okay? So 65 plus X needs to be greater than or equal to $125, okay? Now I'm just going to solve. So I'm going to subtract 65. So I'm going to have X is greater than or equal to 60. So we need at least $60 to go on this trip. If I earned $70, can I still go on the trip? Yeah. You just need a minimum of $60. All right, I'm going to erase. You have $18.50 to spend on a pizza. It costs $14 for a large pizza plus 75 cents for each additional topping. how many toppings can you possibly afford to buy the pizza? Okay, so the most amount of money that I can spend is $18.50. So my equation needs to be less than or equal to $18.50. Do I need to spend all $18.50? No, that's the maximum amount that I can spend. I know it's going to cost me $14 no matter what, but it's going to cost me 75 cents per topping per X. Okay? And now we're just going to solve. So I'm going to subtract 14 from both sides. So I get 0.75x is less than or equal to 450 or 4.5. Then I'm going to divide by 0.75. So x needs to be less than or equal to 6. So we can at most buy 6 toppings at most 6 toppings. If you just write the x is less than or equal to 6, that's fine. But that's just telling me that at most I can buy 6 toppings. I don't need to add 6 toppings. That's a lot of toppings. But 6 toppings is a lot. But buy up to 6. Okay, can I erase? Does anybody tell me this? No? Okay. You can't be talking to whoever's talking to you shouldn't be talking to you. You got a test. All right. Your test grades are at 88% and 93% and 86%. What must you get on your 4th test to have an A for the class? An A's are given for 90% or above. So we are going to need to find the average. How do I find the average, Miss Carol? Yes, we're going to add them together and divide by however many there are. So I'm looking for what I need to get on my 4th test. So that is going to be my x. So I'm going to take my 88 plus my 93 plus my 86 and plus my 4th test, which we don't know is an x. And we're going to divide it by however many tests there are. There are 4. And this needs to be greater than or equal to our 90%, okay? That's what we're trying to do. Our average needs to be greater than or equal to 90%. All right, so now I'm just going to combine like terms. So 88 plus 93 plus 86 is 267 plus our x and divided by 4. Oh, sorry. Thank you. 267. Yes. Now, how do I get rid of my fraction? What's up? I'm not doing no rounding up here. So that leaves 90%. So we're going to multiply both sides by 4. So I'm going to get 267 plus x is greater than or equal to, well, what's 90 times 4? 360. All right, then we're going to subtract 267 from both sides. So x needs to be greater than or equal to 93. So we need at least a 93%.